Hello, good day. I hope you are doing fine. My name is Hasnan Ali, and today I'll be presenting my three completed tasks for the Cybersecurity Analytics course. I have prepared a PowerPoint presentation to guide my presentation. Task 1 was to conduct an investigation on an organization's web server application to identify malicious attack activity using Python data science libraries. UWE Cyber Solutions provided us with recent log data records, and we were asked to identify any suspicious activities that occurred in the dataset. Here are some of the questions we were asked to answer as part of this task, such as the number of unique machines that access the web server application and the minimum value in the SC status column, and the number of entries with before or after some specific time, and then entries in the data column CSURI query and something like that. For the analysis of the dataset, a Python code was basically written. The Python code was used to filter the data using regex and identify suspicious activity. So basically this code reads a log file named datalog.txt, the log file provided for assignment, and searches for suspicious activity that could indicate a cyber attack. The log file contains information about HTTP request. The code splits each line into fields and extracts the IP address, requested URL path, and HTTP status code. The code then uses regular expressions regex to check if the URL path contains suspicious patterns. Specifically, it looks for patterns that might indicate a directory traversal attack, or a command injection attack, or a file enumeration attack. If any of these patterns are found, the code prints a message that includes the IP address of the suspected attacker. Task 2 involved investigating a URL database to develop a DGA classification system using machine learning techniques. The objective was to identify malware families using a machine learning approach. So basically, slide 4 shows the experimental design of feature engineering to characterize the data, which we experimented with different schemes of feature selection and showed how they impacted the performance of the classifiers. Here, three different classifiers using the scikit-learn library were compared: logistic regression, a random forest classifier, and multi-layer perceptron classifier. Logistic regression is a linear model that works well for binary classification problems, but may not perform well for complex datasets with non-linear relationships. Random forest classifier is an ensemble method that combines multiple decision trees to improve accuracy and reduce overfitting, but can be computationally expensive for large data sets. Multi-layer perceptron classifier is a neural network based model that can learn non-linear relationships between features, but may require more training data and tuning of hyperparameters for optimal performance. So basically in the task, confusion matrices and performance matrices such as accuracy, precision, and recall were used to evaluate the performance of each classifier, and reflected on how and when the set of feature selection and model parameters maximizes the performance of the classifier. Task 3 required us to deploy a virtualized infrastructure and conduct an attack against a victim machine while being able to detect it within the SIEM environment. Goibinju was used for simulating the attack, and the vulnerability exploited was improper neutralization of special elements used in a command injection. Its identifier is CWE77. Docker images such as attack box, Sarikota, Alpine, Kibana, and Tomcat were pulled, and containers created from them, where they were set on a subnet where the attack was conducted. This code was injected from that attack box into a command that was executed by a web application that was run by Tomcat server. This vulnerability allowed the attack box to execute arbitrary commands and gain unauthorized access to the target operating system. Using Suricata and Kibana, I able to identify the attack using Suricata and Kibana, which showed exactly the source that the attack came from and at what time. This kind of monitoring is a great defensive measure for cyber attacks. With the ability to detect and respond to an attack in real time, the damage can be minimized while preventing it from spreading further. In conclusion, I want to say that from the three tasks, I have improved my expertise in conducting investigations, developing machine learning tools, and deploying virtualized infrastructure. Thank you very much for your time. Have a good day ahead.